Hello, and welcome to AV Cyberactive.
Modern web applications can consist of many components which are often running within application containers. Each component must be monitored to detect intrusions. In this course, I'll explain various ways that monitoring can be enabled in Linux, on individual hosts, in Windows, and cloud computing environments. Next, I'll forward log entries to a central logging host in Linux and in Windows. I'll then monitor cloud-based web application performance. Moving on, I'll download and configure the Snort Intrusion Detection System, or IDs, by creating ID rules for Telnet and ICM network traffic. Lastly, I will analyze packet captures for suspicious activity and mitigate monitoring deficiencies. As an IT professional, have you ever felt overwhelmed with keeping up with all the latest technological changes in hardware and software, and also tracking hardware and software devices at work that you might be responsible for? That's where monitoring comes in as being very important. Instead of us having to worry about checking in on servers and web applications and log files, instead, we can have monitoring solutions that will automatically detect security incidents for us and notify us. The monitoring is important certainly to detect security incidents, but also to improve application or host or even overall network performance. Monitoring can also be absolutely required for regulatory compliance or maybe to adhere to certain security standards. We can monitor at the individual host level, whether it's a physical server or a virtual machine with a web server stack, or maybe even not a web server stack. We shouldn't be focused only on hardening web servers because we know more than that. We know that we should be hardening everything in the entire ecosystem where that web server is running. And so that might mean in a Linux environment with bash scripts or using PowerShell scripts on any platform. We could schedule those scripts, maybe to monitor logs on hosts. In Linux, we can schedule cron jobs. In Windows, we might schedule a Windows Task Scheduler item to do that. We might even configure our scripts to do regular expression pattern matching, looking for certain types of items like credit card numbers. Now this would be a manual way to monitor for sensitive data on hosts, for instance, and there are certainly other tools that will do that for us automatically, both on premises and in the cloud. Monitoring hosts at the Windows level certainly means keeping an eye on event viewer logs. Now, that can be done manually, or we could have alerts set up to automatically notify us when something specific is written to a Windows event viewer log. So looking at event severities, so looking at warning versus informational versus critical, or looking for security log on failures, looking for specific event IDs. Or even configuring log subscriptions to forward log items from Windows machines to a centralized Windows logging host. Or doing the same thing in Linux with syslog forwarding. Syslogging means next generation. So that's host monitoring. We also have individual device monitoring. Think network infrastructure devices like switches and routers or Wi-Fi routers, VPN concentrators, network printers. All of those items are very important because any one of those items could be compromised by a malicious user, and that malicious user could use lateral movement to connect to web servers on the same network. And that's why we're so concerned about even many things outside of web application servers. So all of our devices, network printers, network switches, if they're going to be enabled for remote management, it should be done using secure protocols like HTTPS or SSH. We might even want to isolate the management interfaces for those devices on a separate VLAN or a separate network where possible. Now that's going to be a problem perhaps for a network printer, where it might only have a wired interface for an Ethernet connection, or maybe only a Wi-Fi connection. Monitoring devices out on the network, which would include infrastructure devices, printers, even servers, can be done using the Simple Network Management Protocol, or SNMP, and ideally version 3, which sends encrypted transmissions. AMIB is a management information based on a device that provides statistics and allows configuration of that device from an SNMP management station. And we can configure alerts so that when those alerts on the device are triggered, then an SNMP trap will send a notification to our management station. So hardening SNMP means changing default read and write strings for SNMP devices and many modern inventorying and monitoring systems still use the SNMP protocol. As we get more specific with monitoring, we get to the application, the web app itself, whether it's running on premises or in the cloud. So we need to track performance metrics because sometimes a long-term spike in, let's say, CPU performance for a web app could be indicative that it's been compromised. Certainly we should be going through app and web server logs or have an automated tool that will look for security indicators within those specific log entries. From a sensitive data standpoint, if we are using indexing for search on our web application, some indexing engines will temporarily store data in an unencrypted form, which could provide an attack vector for sensitive data that's been indexed. So that might be something we want to disable or use an updated component that doesn't result in temporary unencrypted files. We should have a web application firewall configured with alerts to monitor our specific web apps and maybe even auditing alerts for the underlying operating system hosting our web app and files. Maybe even file integrity monitoring, so we know when critical files have been modified by unauthorized users. Monitoring network traffic using a packet sniffer station requires special configuration in a network-switched environment. So pictured in our diagram, we have a 3-port switch with 3 devices plugged in. Now the device with the green screen we're going to say is our analyzer station where we're running packet sniffing software such as Wireshark, let's say. Now in order for us to capture all network traffic on that switch including seeing conversations from other devices, we need to configure the switch that our device is plugged into so that all network traffic in the switch is copied to it. Therefore we'd be able to see it with our packet sniffing tool, and this is often referred to as a switched port analyzer or a span switch port configuration. So with monitoring solutions, we need to make sure that we can determine whether or not we have a security incident. And there are security indicators that can tell us that maybe something suspicious is happening, such as excessive outbound traffic from our internal network out to a single host. That could be indicative of an infected machine or multiple infected machines, which we'll call zombies or bots that are going out to a command and control server under malicious user control to receive instructions. Or incremental port scans on our network, one host after another. Now, while that might be done legitimately, if that happens at strange times, like in the middle of the night where we wouldn't normally do that, then that could be an indicator of someone performing reconnaissance, maybe doing map scans. Depending on the devices you're using on your network, you might also be able to configure them to perform remote scans like Cisco NetFlow traffic analyzing on Cisco devices. So they can actually do the network capturing and analysis and even forward it elsewhere for further analysis. Oh, when you think about monitoring to harden your web application, think beyond just the web A and the web server hosting it, but also to the surrounding network environment. The timely detection of potential security incidents and the response that goes along with that is very important in securing web applications. But one part of this is filtering out irrelevant data. In other words, false positives. A lot of cybersecurity professionals really suffer from security incident false alarm fatigue, we'll call it. Too many reports or alarms on something that might be a security problem when in fact it really isn't. So one key with proper security incident detection is making sure you filter out or weed out all the noise and keep only what is truly relevant. So that means being able to somehow, in a reliable manner, identify suspicious activity and remember. What I consider to be suspicious activity on my network might differ than what you would consider to be suspicious activity on your network. It is unique in its configuration for each and every web application, web server, and network environment on which that web server is being hosted. The Security Content Automation Protocol, this is just normally called SCAP, is a software solution that is designed to keep it easy for technicians to keep up to date with cybersecurity threats. We know those are changing all the time. So what happens then is we have an automated way to compare our network hosts, devices, network appliances. We can compare their current security configurations against a security baseline. Now that security baseline might be a standardized security baseline for compliance, let's say with PCI DSS. Or it might be a security baseline that we have customized for our specific environment. So what we can do then is easily identify any compliance violations related to this security baseline comparison, which further allows for vulnerability management because you might be able to determine that we've got some non-compliant configurations for web servers. That's where we need to focus our energy to harden them. So the components in a SCAP ecosystem consist of SCAP content modules. So, for example, the National Institute of Standards and Technology, or NIST, and many other third parties have security configuration baselines that you can download and use. An example of one of these from the NIST is the Federal Desktop Core Configuration for U.S. government agencies. So beyond these SCAP content modules, we also have a SCAP scanning engine. And this is the actual workhorse that compares the security baselines against our configurations out on the network. We talked about reducing the noise, so let's talk about true and false security indicators. We want to make sure the only alerts we get really do imply that there is some kind of a security incident that is occurring or has occurred. A false positive means that we've got some kind of an alert or an alarm, but it's not true, it's false. Such as an alert that says there's malware on the system, when in fact maybe there's not. It could be that there's temporary app installation files and the virus scanner is thinking that that is malware. So a false negative might come in the form of the downloaded file is free from malware. There are no worries here. However, it might actually be an infected file, it just didn't get detected by your virus scanner. So the malware might use obfuscation techniques or directive name replacement to prevent malware alerts. Then we could have a true positive such as a network distributed denial of service attack is currently in progress. A true positive means that this is correct and it is happening. A true negative might come in the form of an alert that states network traffic volume looks normal. There's no problem here. Well, that means that the activity might be acceptable and it truly is. So the negative part comes from that there's not a problem here, but it's true, there is no problem. But in order for all of these to be able to work correctly in an enterprise, you have to have a baseline of what is normal in your environment and on your web application servers. In a larger enterprise, we don't want to have to go to individual web servers to look at log entries and so on. We don't want to have to go to individual firewall appliances and look at their logs. Instead, we want to use something like a Security Information and Event Management or CM, sometimes pronounced CM system. What happens is we can configure our CM solution to ingest activity from multiple sources, from firewall logs, from web server logs, individual client device logs, all of it gets ingested into a central location. The CIAM solution will then perform event correlation and event analysis, and if it detects that there are security incidents, then we can get real-time security alerts. Often these types of systems use machine learning to learn what is normal versus abnormal, what looks suspicious, in order to reduce the amount of false positives that are sent to cybersecurity analysts. What often goes hand in hand with that is security, orchestration, automation, and response, otherwise shortened down to SOAR. The purpose here is incident response in an automated fashion. So if we have our CIAM system that detects something that looks suspicious, we can have a SOAR solution that automatically does something about it. The idea here is that we can have automation via what's called a playbook, so instead of having technicians physically solve a problem as it occurs, and that's still very important. Instead, a SOAR playbook can do that in an automated fashion, which might actually reduce incident response time. So here we have an example of a SOAR playbook. It's basically a flowchart for automation of dealing with potential security incidents. In this case, it's dealing with a suspicious email message that might have been received. And then if it contains a URL link or a file attachment, then maybe sending that off to a detection tool online like VirusTotal to determine if we've got a malicious file attachment or a malicious link, and then doing something about it, such as deleting the email so that the user doesn't even get a chance to click on the link or open the file attachment. One important aspect of securing a web application is monitoring its performance. So to get started here, we're going to deploy a Microsoft Azure web application, and then we're going to make sure we enable something called Application Insights so we can track the detailed performance metrics related to that web application. And so to get started here in the portal, I'll click Create a Resource in the upper left and I'll choose Web App. We're going to deploy a web application, which is otherwise called an app service in the Azure cloud, and I'll click the Create button. Next, I'm going to deploy this into an existing resource group and I'm going to give this a unique name. The web app name needs to be unique, so I want to follow organizational naming standards while making it unique. And notice it's going to add the .azurewebsites.net DNS suffix to the end of my website name. So having done that, I'm going to make sure that it is a code-based app. It'll be, let's say, net-base.net 5, and I'll deploy it in Central US. It's going to create an app service plan which controls the sizing, the underlying horsepower for the web application. I'll click Next. There's nothing I'm going to change in deployment. However, for monitoring under the Monitoring tab, this is why I want to make sure that I do enable Application Insights. Now there are times when that won't be available. For instance, if I go back to basic say, and if we were to say this is a code-based web app, but server-side maybe what we want to use, let's say, is PHP. And if we were to jump ahead back into monitoring, then notice Application Insights is not available for that particular platform. So I'm going to go back to basics then, and I'm going to change it back from PHP all the way to being .NET 5 specifically in this case. And now when I go back to monitoring, of course Application Insights is available. So here it's going to create a new Application Insights object in the cloud. So that's fine. I'll click Next for tagging. I'm not going to add tag data here. I'll click Next for review and create, and it validates my selection. And then I'll go ahead and create the web application. And after a moment or two, the web app is deployed. So I can either click Go to Resource to open it up, or I could go home and then perhaps go to the All Resources view. Now, normally you might have hundreds, perhaps even thousands of objects here, and so it's important to know how to filter. So I could filter by name. I could start typing in, for example, web, knowing that it's called web app, and so on. We can also filter by type, where we could simply put a check mark next to the item that we want to make sure that we are looking for. However, here we've got our web application, so I'm going to go ahead and open up the app service. Okay, so when we go into the app service then, or the web application in the overview blade over on the right, currently the app is up and running. Now we know that because of course it says stop, but we also have a URL, and this URL is prefixed with HTTPS. Okay, well that's good. And we've got the name of our web app with what we saw earlier, the default azurewebsites.net DNS suffix. And of course, we can click just to verify that the web app is running. And indeed of course it is. Everything is perfect. But what we want to do over on the left-hand side in the Navigator for our web app is go all the way down into our monitoring section. So here on the left, we can click Alerts, where we can start configuring alert rules. For instance, we might want to be alerted when certain conditions are met, so we can add a condition. And here we might look at the number of connections or the amount of data into or out of the app, the CPU time for the underlying virtual machine for the app. So we could specify all of those items that we might want to generate an alert from. And of course, because it's a web app, maybe looking at HTTP error codes, for example HTTP 401 errors. Where a 401 error means that there is a lack of validation to access a resource. In other words, some kind of authentication problem. So maybe that's what we want to add. So for instance, I might add that, and as we scroll down, what I get is a little graph where I can specify the time span. Let's see over the last week. Well, we might have had some 401s, now it's a new application, so of course we don't have any. But nonetheless, down below we could go down and specify that if we have more than a total, let's say of 541s. then maybe that should trigger this particular alert. Okay, so it's going to evaluate that every minute. So if you have more than 5 within 5 minutes, we want this triggered. We can click Done, and then down below we can configure an action group which to. For instance, if anyone is notified, I've already got an East Admins action group I've created previously with an email address for a group of admins that could be notified. So I'm going to select that and I'll add that. And then I have to give this rule a name, so maybe I'll call it check for 01, and down below I'm going to go ahead and create the alert rule. Okay, so now we've got that alert rule. If I click refresh, whenever it's triggered, we'll have alerts that show up here in the alerts view. And of course in my particular case, it'll send off an email. Now we can also click metrics over on the left to start looking at metrics related to our web application, let's say number of connections. So it looks like it spiked up here when we've just created the app because that was me testing that application. But what if we used a tool like OWASP ZAP, let's say to test this web application, and it was making a bunch of connections? Would that affect the performance? It would. We would see that activity. So why don't we go ahead and do that? Okay, so here in OWASP ZAP, I'm going to choose Automated Scan and I'm going to go ahead and paste in the URL for our Azure web application. Having done that, I'm then let's say going to choose. I want to use Chrome headless. I don't have Google Chrome installed here, and I can even begin an attack, assuming that I wanted to test web application security. And again, we can see it's testing all kinds of aspects of that application. What we'd really be looking for if we were actually running a test here was just going under alerts to see if there was anything specific. But let's flip back and check out the performance of the web app for a sec. So back here in Azure, we were in the web app properties and we had clicked metrics over on the left. And so from here we can take a look at, for example, the number of connections we were talking about. So let's say I want to go ahead and just take a look at that and we see that it's been plotted, but we can also specify other types of metrics. So if we want to look at CPU time related to our web app or data in, data out, all of that stuff gets charted here. Over time, we can also click Health Check over on the left. What this does is it keeps track of the underlying virtual machine or virtual machine supporting the application, and so if we have an unhealthy back-end virtual machine, it'll be restarted automatically. Now that sounds like a good idea, so we could turn that on if we wanted to. Now also we have enabled Application Insights, and that's kind of in a different area. If I scroll up on the left under Settings, this is where I'll be able to click Application Insights. Now that's already been done, and it's been linked to our Application Insights resource, which if we go back to the All Resources view, it's actually a separate type of object. As we can see under the type column, it's Application Insights. That's the object type as opposed to the actual app service or the web app. So if I open up the Application Insights, then we can start drilling down in here to get more details about what's happening with our app. So over on the right, immediately we see things like failed requests, server response time, if there are any, the number of server requests, and we can specify the time frame over which that might have occurred. Now back up here on the left under Live Metrics, we can also click the View in Logs button up at the top where we can start, for example, by clicking Queries on the left and selecting specific types of queries that we might want to run against gathered data. Like Page Views Trend. So we could select that and run the query, and if there is any results that will show up in the bottom right or the top 3 browser exceptions that we might have run into the slowest pages, we can select that. And again, we're not getting any results yet because we have a brand new application, but over time you're going to start to get a lot of stuff showing up here. There's also a performance category, an alerts category, and finally a reports failures category. Security monitoring means having a way to detect intrusions. Now this is done using sensors on the network for intrusion detection and possibly prevention to block attacks. So what these devices or software configurations will do is they will ingest data and then analyze it. Now this data could be the result of capturing network traffic. It could be the result of having host and application logs for their events to a centralized location for ingestion and analysis. But the idea is that we need to filter out the noise. The way that this is normally done, the way that we reduce false positives is by tweaking and configuring intrusion detection systems. To really only look for certain types of attacks, or maybe to configure them to look for certain types of behavior, which could be indicative of something suspicious, and then specifying where to send alerts. So we're talking about seeking out indicators of compromise. That means comparing what is normal on our network, having a baseline of normality that is compared against current activity. Intrusion detection comes in the form of host-based intrusion detection. This is used when we want to be able to detect any security incidents that might be related to phishing email messages, let's say, that might contain malware or removable media that's inserted that might be infected, or even perhaps blocking the insertion of removable media that would allow reading and writing, say, to flash drives physical access to devices. So we know that if we have physical access to a disk and the contents of the disk are not encrypted, then it's easy to read the disk contents. Host-based intrusion detection can also take a look at software vulnerabilities, maybe missing patches or suspicious behavior for apps running on a host. At the network level, a network-based intrusion detection system can potentially detect unauthorized network access. Maybe by comparing what is normally expected to be on the network against what's currently on the network and picking out the changes. Intrusion detection at the network level can also be based on detecting any network scans that might be unauthorized or rogue wireless access points that aren't authorized to be on the network by the IT department. So an intrusion detection system then, or an IDS, can be host-based where it looks at file integrity monitoring to determine if files have been tampered with. It can use app and user behavior analytics to identify something suspicious without actually matching it to a known pattern or a known signature of attacks. Network-based intrusion detection systems use sensors, which can come in the form of hardware appliances, or it could be software running on a host, plugged into a certain place on the network to capture relevant network traffic. So network traffic analysis, wireless intrusion detection systems, or WIDS, and so on. IDSs are designed to detect and then maybe log any suspicious activity and alert or notify technicians about this activity occurring. Intrusion prevention takes this a little bit further. So intrusion prevention really is the same as intrusion detection at the host and network level. But it takes it a step further because it can actually be configured to block attacks, maybe to block suspicious activity stemming from a given IP address, block that IP address, or maybe slow down the rate of data coming in from that location. So DNS domain names can also be blocked. To mitigate things like distributed denial of service attacks or DDoS attacks, even mitigations like black hole routing can be used essentially to route excessive traffic to nothing so it doesn't actually reach the intended target. Snort is a free open-source intrusion detection system that runs a software such as on the Linux, Unix, or Windows platforms, and it uses a number of rules to determine what it will look for in terms of suspicious activity and what it will do about it. So here in our example, we're looking in Linux at the contents of etc. This is where you can configure your own custom intrusion detection rules. We have one here that is alerting on ICMP network traffic. ICMP traffic might stem from someone trying to ping something on the network or using commands like traceroute. Those commands both use ICM as their underlying protocol. Now, besides defining your own custom rules, there are also plenty of other standard rule files that will detect standard known attack attempts. If we were to look at a placement diagram, here we have a potential target shown in the bottom left and the attacker in the upper right out on the internet. Now most networks will have multiple layers of firewalls. Here connected to the internet we have an exterior firewall and next after that we have a DMZ, a demilitarized zone, otherwise called a screen subnet. This is where you would place servers that should be public-facing. Maybe hosts that are running public-facing web applications or load balancers, that type of thing. And the exterior firewall would limit traffic directly from the internet into the screen subnet to specific hosts on specific ports like 443 for a web app. The interior firewall, however, would not allow traffic directly from the internet to pass through. Instead, the interior firewall here might allow internal traffic to go out to the internet. We also have a network switch on our internal network where we have a device plugged in to capture and analyze network traffic. So that means the port that device is plugged into might be configured to copy all switch port traffic for all things that are plugged into that switch to the port where this device is plugged in, and it might be set up for intrusion detection. So it might be a network intrusion detection system NIDS that's configured with alert notifications. So if it detects suspicious activity such as an attacker somehow trying to get into that target, now they wouldn't be able to do that directly, but the attacker might be able to compromise a server in our screen subnet, and depending on how the firewall rules are configured, if that server maybe needs to send log information to an internal centralized logging host, then the attacker might be able to compromise the web server and then use that as a mechanism to get into an internal logging host on the internal network. Hopefully that doesn't happen, but it is possible. So the placement of the intrusion detection sensors then can be important. If we're interested in detecting intrusions to our public-facing web apps, naturally the intrusion detection sensors should then be on the screen subnet to detect that kind of traffic. Intrusion detection and prevention is critical in determining if there is suspicious activity occurring on the network or for a given particular host. In this case, we're going to use the Snort IDs. That's the Snort intrusion detection system, running on Linux to detect if there's any type of specific traffic that might be suspicious. So abnormal, not normally sent on our network, such as telnet or maybe even some ICMP packets like for pinging. Now we could write rules that would look at just about anything. However, in this particular case, we're going to go with that. Now here on the snort.org web page, you can actually go to downloads. And you can actually choose to download Snort on a number of different platforms. So it doesn't have to be Windows, although there are executables for that purpose. But there are also the source files that are all zipped up. And then there are some binaries for different platforms like RPMS. And also we've even got some changelog information on what's been changed. And then we've got MD5 sums or hashes that we could run after we download one of these files, just to make sure that it hasn't been corrupted during the download. But what's interesting too is we also have the option if we go to downloads at the top of downloading rules or rule files. So we've got a number of items that are available such as Snort version 3, community rules.tar.gz. So we can download that and unzip it to see what some of those rule files look like. So I'm going to go ahead and download that file just for fun, then we'll take a look at it. So I'm going to go down here in the bottom left and choose Show in Folder since it's now been downloaded, and I'm going to right-click on that file. I'll choose 7-zip and we're just going to extract it out. Okay, so it looks like we've got it here. And again, I'm going to extract the TIRE file, that's an old Unix standard for tape archive. It's just a compressed what might be a compressed file, but it's certainly an archive file, so I need to extract it. So I'm going to choose Extract here. I'm using the 7-zip tool. And what I'm interested in looking at is the Storm 3 community rules file. So why don't we just go ahead and open that up, let's say perhaps with WordPad or something like that. It's just a text file. So within this file, if we just kind of maximize this and let's say we zoom in and all that stuff, as we go further down, we have a lot of rules that are shown here. Now some of them are commented out, of course, with the hashtag or the pound symbol. But what we have happening here are a lot of alert messages, and here it's for example looking for certain types of activity destined for a specific port number on our home network. $home_net is a variable, and here it's going to display a message about malware for a backdoor worm client trying to access hosts. And so these are very important files that we might want to use. And of course, we can write our own rules as we see fit when we are using Snort. So I could run Snort on Windows. I can also run it in Linux. For example, on a Linux host I could run sudo apt install, let's say snort to install it. I'll enter my current username's password because I'm running the sudo elevated privilege command. Now if it's already installed, we're good. Here it says snort is already the newest version, otherwise it would install it from package repositories out on the internet. So we're good to go. Snort is here. If I type in snort by itself, yep, it knows what the snort command is, so that's good to know. Now what I want to do here in Linux is I want to run sudo nano /etc/snort/snort.conf snort configuration file. Now this isn't a rule file, this is the overall config file for the snort IDs engine. And as I go down, for example, what I'm going to notice are a number of variables. For example, I've got a variable called home_net, which is currently set to any, although I could change that for instance to be my home subnet range 192.168.4.0/24 for instance, or whatever the case might be. And so I've got a number of these variables here that I can change, and these variables can be referenced within my rules, such as $home_net. Notice that when we reference the variable, we prefix it its name with a $, but when we define it up here at the top, there is no $. So that's important to note. At any rate, I'm not going to really save that change. I'm going to press Ctrl X. When it asks save modified buffer, in this case I'll type in the letter north and we're back out O. At this point, we know that snort is installed. We have a sense of the snort config file and some of the variables in it, and we know about snort rules. As a matter of fact, actually if I were to do su, well actually let's just do this ls/etc/snort/rules. And notice here we have a number of rules that are here already, all kinds of them. Now there is one file in here if we just kind of bring up the previous command and let's say local. ****. So let's see if there's any rule files with the word local. There is. There's one called local.rules. This is normally the one that you would edit yourself and put your own custom rules in that you want the snort IDs to use. So an important part of intrusion detection then is knowing which tool to use, such as snort, and at least getting it downloaded and having a sense of which files are used to perform the intrusion detection. The free open-source snort tool is an intrusion detection system. Now here I've already got snort installed. As evidenced in Linux, if I simply type in snort by itself and press enter, it recognizes the command. Now from here I can also get help on how to use the snort command by typing snort h. And if I scroll back up through the output, sure enough we see all the command line parameters on how this intrusion detection system can be used. Now the purpose here is we want snort to be able to alert us when something suspicious is happening. We don't want to have to go through server logs looking for what may or may not be suspicious activity. We want snort to tell us. Now there are a number of pre-configured rules. Looking for common suspicious activity or malware, but we can also tweak this for our own specific environment. If I were to run sudo cat/etc/snort/snort.conf the config file and pipe that to more to stop after the first green fall, we'll be able to go through and take a peek at this configuration file for snort really. What's important here is we have definitions for a number of variables like homenet for your home network versus telnet servers versus SMTP servers and so on. And these can be used when you are writing snort rules. Now also if I were to run sudo let's say ls/etc/snort/rules. We have a number of rule files. They all end with .rules. So community rule files, some that are specific to DNS, suspicious activity or denial of service rules or FTP rules and so on. We've got a lot of rules here that we could work with and they're automatically set to be used. For example, why don't we take a look at how about exploit.rules? That sounds interesting. So if we were to run sudo cat/etc/snort/rules/exploit.rules and we'll pipe that to more. And as we go down through this file, we have a lot of alert rules here that are going to display a message of some kind, such as an exploit for Netscape or whatever the case might be. But what we can also do is run as you do, let's say cat of etc., and what I might do is grep that or pipe it to grep the line filter looking for XSS cross-site scripting. So will Snort try to detect any kind of cross-site scripting attacks against our web app? Oh yes, we've got a lot of hits here where it's going to be looking even for that. Now that's not to say that Snort is a web application firewall. It should be used in addition to a web application firewall, but it does look for a lot of these items. So the interesting thing here is you can check your rules for anything that you think might be of interest. If I looked for CSRF, cross-site request forgeries, nothing. If I were to look for other things like directory traversal, and put that in quotes, yes, that does show up. We have a lot of hits. So the point is, there's a lot of stuff that this is doing out of the box for you when it's running. Now we've not yet started Snort, but we'll get there in a minute. But the first thing I want to do is actually open up. So I'm going to run as you do. I'm going to open up with a nano text editor /etc/snort/rules, and I want to open up the local.rules file. Here I've already added a custom rule, so let's go to alert of any ICMP traffic from any network, any port going to our home network, any port number, and the message will be testing ICMP, and I've got an ID here of 1,000,001 revision 1. Now each of these specific components here is separated with a semicolon. The full colon separates an item like rev for revision against its value, in this case 1. And the class type here is an ICMP event, so that if I have any ICMP traffic, maybe traffic generated as a result of the ping command against this host or trace route, then this will be triggered and we'll test that out. Maybe we'll ping this Linux host to see that our testing ICMP rule actually shows up. At any rate, I'm going to press Ctrl+X to get out of that file, so we've got that added so you can add your own custom rules based on whatever you want to do. However, it means having a bit of an understanding of the syntax within the Snort rule file whenever you make a change. Change to a rule file or the configuration of Snort in any way, you want to make sure that it's valid. So we can do that with sudo snort-T for test and -ith0 because Snort has to listen on a network interface and -c for the config file which by default is etc. So I'm going to go ahead and press enter on that. And what we're looking for at the bottom is that Snort successfully validated the configuration. Excellent, we're ready to go. What that means is we're ready to start Snort. We could do that with sudo snort-A for alert to the console-q, which means quiet mode, and finally -c for our config file of /etc/snort/snort.conf. So it will automatically use our rule files. And right now it's in listening mode, so we're going to test this. I'm going to ping this Linux host from a Windows host to see if our testing ICMP rule gets triggered. So here from a Windows box, we're just going to ping 192.168.4.108, which I know is the IP address of our Linux host. And sure enough, we're getting a reply back. Well, that tells me that it's not been firewalled to prevent that type of ICMP traffic, but let's go check our Linux console to see what's up. Sure enough, we have a lot of testing ICMP messages for each of the echo requests that were sent from our Windows ping command. Now notice we also have a couple of other rules that look like they have kicked in, such as universal plug and play or UPnP, some kind of scan or discovery attempt, and that might be normal for devices on your network if they're enabled for universal plug and play. So it's reading all of the rules from the files and displaying the alerts. Discovering what might be considered to be suspicious activity on a network can be automated using intrusion detection systems. We can even automate the response using a SOAR type of solution. However, we also have to have a sense of how to manually see things that might appear suspicious, and in this case it would require a knowledge of some standard Internet protocols. Here we're looking at RFC or Request for Comments 1464. These are standards documents on things like Internet protocols like DNS, Domain Name System. Specifically, what we're talking about here are DNS, text or DNS text records. So the idea with the DNS text record then is in the DNS server, which we normally use to resolve names to IP addresses. We can use a text record to store information that is retrieved for maybe determining something like the name of a printer. And here there's an example in the RFC even for favorite drink equals orange juice. Of course that's probably not something that would really be used, but the point is this DNS-TXT record isn't used to resolve names to IP addresses, which is what clients normally do. Instead, it's used to store some kind of information. Now, from a security or malicious user standpoint, imagine that an attacker would store commands or redirection URLs here for infected machines. So they would go out and do a DNS-TXT query to find out where the command and control server is that they should be reaching out to. And these days, that also happens through even fake Facebook accounts and Twitter accounts where instructions or redirect URLs are stored and read by infected machines, otherwise called bots. So here in Wireshark I have a packet capture which I'm going to filter by the DNS protocol. So I'll type DNS at the top and press enter. And immediately I notice that there are a lot of queries for text records. Okay, so I can select one of those packets. Of course I have access to the source IP address and the destination. Now the destination here looks like 8.8.8.8. That sounds like it's probably a Google DNS server. So for instance, here from the Windows command line, I'm going to run nslookup and I'm going to set type equal ptr. That's a reverse pointer lookup and I'll just type in 8.8.8.8, see if it returns any name information. And sure enough, it looks like this is part of the Google DNS set of name servers. Okay, so that we've determined so far. And of course, if we drill down in the packet headers, we know that client DNS queries happen over UDP where the destination port is 53. Okay. And if we look at the actual query, we can also see the details down below. But what is actually happening here? Looks like we've got a query for WoW, name server. Okay, so why? First of all, we have to ask yourself, why is a client issuing this type of a DNS query? It's not normal, not for DNS-TXT records, DNSA records. To resolve names to IPS. Yeah, that makes sense. This feels abnormal. So what we're going to do is upload this to an online scanning service to see if it detects anything strange. So I've gone to the Aristotle.com site where I can upload files or specify URLs just to see if they look suspicious, if there's anything wrong with them. So I'm going to go ahead and choose a file down below. And what I've done is specified the packet capture file that we just looked at and it automatically flips me over to this results page where it looks like from a snort detection utility perspective, it's detected 2 alerts and we can click on it to see what's going on. So what does it think is an alert here? Scroll down immediately commands over DNS text queries and responses. Now this is known not to be normal. For a client DNS query activity and as we go further and further down, we have a list of the DNS requests from that packet capture. So it takes that packet capture and analyzes it and presents it in this nice easy to digest format. So we see miscellaneous activity. We also see the attempted user privilege gain, so it looks like a specific type of firewall client exploit. So it's safe to say then that we've got some serious problems occurring here as a result of this capture. And if we click on Community, we might even get some details related to what other analysis results have determined to be similar. And if I go back under Details on the left, let's say, and if we scroll all the way down, let's say under Sericata Alerts, then if I go into a network Trojan was detected here. Here it's giving me some more details. It's pointing me in the same direction that we originally thought via the packet capture, that we've got some kind of a Trojan piece of malware on the inside that's going out to Google DNS servers, retrieving information via text record queries, which is usually going to be used so that the infected client knows who or where the command and control server is. So there is value then in simple packet captures. You might schedule them to occur randomly, and you might also make sure they run for a long period of time. Save the packet capture files and immediately. The quickest thing to do is just upload it to an online service like this, as opposed to trying to pore through it manually, because you never know what kind of indicators of compromise might result from that activity. So what can be done then to mitigate monitoring deficiencies? Well, quick answer is to enable monitoring, but there's really more to it in reality. Basically, we need to consider the fact that we can't secure something we don't know about. If we don't have monitoring in place properly, that's letting us know that there are anomalies out there on the network or for a given web app. How could we possibly take steps to remedy that situation? We have to know about it in the first place, whether on premises or in the cloud. Now, one way to deal with log monitoring is through log forwarding. So instead of going to each and every device, looking at logs, whether they're network switches, routers, web servers, user desktops, firewall appliances, instead of doing that, why not configure them all to forward their log entries to a centralized place? So sending a copy of some or filtered set of log events to a different logging host. You'll see this used a lot with honeypots. Honeypots are fake or decoy systems that are intentionally made to look vulnerable to attract malicious users so that we can track the techniques that malicious users would use to try to break into that type of device, whatever the honeypot is emulating, whether it's a Windows server, a Linux server, or a PLC in an industrial control environment, whatever the case is. But really, log forwarding should be used for everything in the enterprise. So user stations, servers, we've talked about network infrastructure devices, web servers, even specific web applications. All of this should be sent to a central location because remember, if an attacker compromises a web server, well, if they've compromised that web server, they probably have the ability to clear out log entries on that server. So we'd like to have a copy of those log entries elsewhere for safekeeping. In the Windows environment, we can enable log forwarding through event log subscriptions. In this example, we have roll call client devices over on the left, which could be Windows servers and Windows client devices like Windows 10. Now on those, we're calling those log source hosts. We would run WinRM, Windows Remote Management QC for quick config. Now you can do that centrally through group policy if devices are connected to an Active Directory domain. But what this does is enables the WinRM protocol, because this is what actually gets used to forward log event items over the network to a centralized logging host. Now on the right of our diagram, we have our Windows log collection host where we would run WEC-util-QC. That stands for Windows Event Collector Utility Quick Config. So we have to enable a listener. Now depending on how you configure your Windows event subscriptions, you can either have it as collector initiated, so our server on the right, our centralized logging host, could reach out over the network every few minutes and gather log entries from our log source hosts. Now could gather specific log entries from certain logs or all log entries. But instead of collector initiated, we could also have it source initiated by our log source hosts, where they would periodically submit their log entries, either all of them or a filtered subset of them, to the central log collection host. The great thing is the central log collection host might be on a different network, a different internal protected network. You can do the same type of thing in Linux with syslog forwarding, where on your log source hosts you would configure them to filter which log entries should be sent over the network, and then it would be configured to point to, for example, the IP address of the central logging host, which is shown on the right of our diagram. Where we would configure syslogging syslog next generation, which would be configured to accept incoming UDP port 514 traffic. Now you don't have to use UDP 514, it could be TCP, it could be a different port number, but that's the standard listening port number for the syslog daemon to receive log messages from over the network. So we know then that centralizing log collection is absolutely crucial in the enterprise. Now the sources, of course, could be intrusion detection and prevention sensors, network traffic analyzers. The target, of course, for that information might be a SIAM and SOAR solution that uses machine learning for threat detection. With centralized monitoring, we then have a central place to configure event notifications for suspicious activity. Oh, the idea is we can have notifications sent to interested parties, maybe via SMS text message, maybe an email notification, a phone call. We might also have a configuration that can stop attacks in progress as they are detected, and a centralized SIAM and SOAR solution can automate incident response, which can result in a reduced incident response time. So in this course, we've examined how to ensure that monitoring is deployed correctly to ensure the timely detection of past security breaches and also security incidents in the midst of occurring. We did this by exploring logging and monitoring. We examined SIAM and SOAR solutions, how to forward log entries using syslogging, and how to forward log entries using Windows Event Viewer subscriptions. We then enabled Cloud Web Application Performance Monitoring. Next, we examined intrusion detection and prevention, installing the Snort IDs and then testing Snort IDs rules. We analyzed suspicious network traffic using Wireshark. And we finally mitigated monitoring deficiencies.